Hi, everybody. Welcome back to Eve, Electric Vision Entertainment. I am your host, Aleia, and this is a show about tech, thoughts, and big hair, where we do coding, we do robotics, and we generally build things, have a fun time hanging out, doing STEM related stuff, talking about technology, different projects got going on, and just building robots. So if you're new here, make sure to follow us on our Twitch, make.sc/Twitch. Should already be there if you're watching this. And we do this every Saturday at 2 p.m. Pacific time. So make sure you tune in every week to see the show. If you are not new here and you've been here before, welcome back. We're going to do some more robotics type stuff today. Last week, we did an intro to electronics. Just having a bit of fun, learning about different parts, the general idea of, the type of things you would need to get started doing robotics. And we didn't get too much in depth about the microcontroller or the brain of the robot, nor did we get too much into how to code them. We kind of just hardwired, like, I think we just did the one green LED last week. So what we're going to do this week is we're going to recreate that same circuit. I have about 5 or 6 different examples for you all. So we're going to do that same circuit, but this time we're going to actually plug it up and program it, as well as we're going to work with a few other ones. So for example, seeing how to work like a buzzer for audio, how to do, like, I showed an example of a ultrasonic sensor. So I'm gonna plug that up, see how that works, as well as a few other things, how to just generally code and get started. What I will do is I will share in our Discord, if you join our Discord, which is make.sc/join-discord, I'll put in there the links to the projects that I'm working on. A lot of the examples that I'm going to show you today are not ones that I came up with from scratch. They're made by SparkFun. And so I'm going to share the link to where they have all of the circuits, examples of how to build it, as well as the code to get you started. But for today, if you want, you can just follow along via the video. And what I am working on for the future is getting or finding a software for us to use, because I know some people want to follow along with us. Thank you for following the Struggling Black. Some people want to follow along with us. And I would love for everyone to follow along. That's the point, is for me to show it to you, for you to do it yourself, and then build your own thing. However, I know that getting all of the parts, getting the right parts, getting set up can be time consuming and at times not the most cost effective. So we're working on finding a software where you can just pull up the starter code or pull up the circuit and wire it yourself visually on the computer rather than having to buy all the parts. Of course, buying all the parts is more fun. So alongside of that, we're going to work on putting together a place where I'll put out the projects that I'm working on and describe all of the parts. I'll put the code that we're building. For example, we'll probably do it next week. It's a bit heavier and it works, but it takes a little time for it to get fully set up. So we'll do that project later. But if any of you have seen the movie Knight Rider, there's this scanner on the car that goes back and forth. A Larson scanner is what it's sometimes called. So I have the code for it. I have the circuit for it, the schematics, and I can share all of that with you all next week when we can talk about more how to design a schematic from scratch. And then we'll build and code it up. That will be probably all of one show because it will take a little longer. For this, like I said, we're just going to go through a few examples of how things are coded, how things are wired, and just kind of go from there. And then at any point in this, feel free to utilize the chat, ask me any questions, suggest ideas for other projects to build, things like that. Clarifying questions, or just generally chit chat with me. Share any experiences you've had working with electronics, any fun things that you've built, resources that you have that you might want me to have, all that fun stuff. We're a community here. So, with that being said, I'm going to go ahead and share my screen that you all can see what I'm seeing. Yes, so first of all, we're going to go, like today is all about Arduino. So we're going to talk about what the Arduino is, how to get set up running it, and then code up a few things. So first of all, we're going to use this guy, which is the Uno. Very simple. We talked about it a little bit last week. We did this other Uno, this Eglio one. But for the purposes of today, we're going to use the official Arduino chip. It's laid out a bit. Well, actually, they're laid out the exact same, actually. But since we're going to use the Arduino IDE, I figure you might as well just keep it pretty cohesive across the boards. We're going to use the actual Arduino chip. And I do plan as well. These, I think, run maybe $30 on average for one of these bad boys. But what I'm also going to show you on our soldering episode, most likely on the soldering episode, I'm going to show you how to make one of these from scratch. So I have most of the parts right now. I don't think they're all here. I'm waiting for like the crystal, which is these pieces. Over here. So there are these chips and this one over here. They're crystals. And they basically keep track of timing for when you're doing like it has to do math. When it's doing like logical things, it needs to keep track and keep time of all of that. So that's what the crystals are. And then you have like headers like this that you use. I probably won't use this one, even though it already has all the headers on it. I'll probably just make one completely from scratch. So I have to buy headers. There's some transistors, which we'll talk about those sometime, probably on that same episode. But transistors are really what got our technology to where it is right now. They were like showcased at the World Trade Show like 60-ish, 80-ish years ago. And they completely like revolutionized technology. Now they're everywhere in everything. They're just infinitely smaller. There are bajillions and bajillions of them. There's a whole theorem about them, and how they affect the evolution of technology and how it's going to exponentially increase. I think the idea was it would double every year, but now technology has gotten so fast and everything that it has went from doubling to increasing exponentially. That's a whole nother conversation. We'll get into that later. Someone definitely look that up. Bonus points if someone knows the law that I'm talking about. I was about to say it and I was like, don't. Bonus points if you know what it is. I'll give you a hint and it starts with an M, but I'm not gonna say what it is. So, with this being said, so last time what we did was we used this Arduino to power our circuit. And you'll see here, I got a different breadboard because I hate my other one, to be honest with you. This one I like way better. It's the same, it's just two of them on there instead of one, and it's bigger. Let's see. And then the positive to this one, it doesn't really help me now because I don't have a power supply, but let's flip it around so you can actually see it. No. Um, 1 second, everyone. Um, Let's get a little more contrast in there. So it's it'll be a little dark, but at the same time, you could probably see things better for everybody. Put it right around there. And then, of course, you all as the viewers, I would ask for you to, give me feedback. Let me know how I can improve this. If we need more light, if we need less light. The camera angle needs to be switched around in the future. We evolve with time, so we'll see what works best. But just let me know, and we'll do our best to improve it. So the positive thing about this breadboard that I like, I said, usually if I had a power supply, if I was working on like a big project, for one, I have way more space on here than on that other board. Two, it just allows me to, for whatever reason, the other board was being stingy and was like not letting me insert things into it. This one was not as stingy. So, and then up here, so you have this symbol, these lines. That symbol is the schematic symbol for ground. And then this one is volts. This is also volts. You can just use either one. But usually what you can do is you can have jumper cables and plug it into the top and plug it into a power supply. And then that way you can just scroll it up, not scroll it up that way. It's a little stuck. Of course they are. There we go. So you can roll it up like that. And then you can insert the wire in between and then just like put it back down. And then that way it's making a connection and you can run the cable from this to the board. And then that way you have power from your power supply all the time rather than how we're going to do it, which is powering it through the Arduino, which is powered through my computer. And this is usually not a problem, but if you're not using an Arduino, you're just, say, plugging in just the main chip, the integrated circuit chip, which I don't know where, I have like 2 or 3 of those somewhere, everywhere. If you're plugging that directly into, like, let's say, practice building a board without having the real one, you're just like prototyping, then you might want to get your power from a power supply. And then that way you can also alternate how much is going through, all sorts of things with those. But I don't have one yet, and I don't know when I'm gonna get one because they are big, heavy, expensive, and I don't know if I really need one at the moment. So we'll see. So that being said, so we're gonna use this cable. It's a serial. It's USB on one side, serial on the other. Pretty simple. You can find them anywhere. They're like printer cables, basically, which makes sense when you see some of the stuff that's going to happen here. So I'm just going to plug that in, the Arduino on that port. And then the other side, of course, goes to my computer. So I'm going to plug that in. And then once it's plugged up, you'll see we got power going again. There's 2 red lights on there right now because I was doing programming on it earlier. The thing about Arduinos that is actually probably one of the benefits for why people use them is once you program it, that program stays on it. It doesn't just vanish once you unplug it. So I think the last thing what was the last thing I plugged up? I think the last thing was like this ultrasonic sensor. So it's still thinking, like if I plug these cables back into it, it'll work. If I plug something else into it, it probably will overheat the parts. I almost overheated some parts earlier. I was a little concerned for a second that I broke everything right before. But luckily that was not the case. So I'm gonna pull up and show you Arduino software where you can get the software for it. Let me get that for you real quick. I forgot to pull this up for you all earlier, but I'll drop the link in the share. Okay, so doing that, let me zoom in a little bit for you. Okay, so if you go to arduino.cc, we'll do this. So you go here and get to their landing page and you have all sorts of stuff about Arduino. They're a very big company, do a lot of really cool things. They have all sorts of kits that you can get for them and everything. And then what you can do is if you go to -en in English and software, then you get to their downloads page. You can download the Arduino right here. So let me drop that in the chat for you all real quick. Software. All right. So I just put that in the chat for you all. You can go there. You can download it for free. Right now I'm on my Windows, so let's just say this guy. And you can download it for free, but you can also, as you see, you can support them and donate. So I highly suggest doing that because it gives us better software to use when we're making cool stuff. So I'm gonna go ahead and do the first circuit. The first circuit is going to be, once it's downloaded, let me pull up the, so this is going to be our first one. It's way over here. There's a lot of things happening on this board today, but let's still to get a little less light. But we're going to do this one over here. Basically, it's just an LED, just like last time. We're literally going to do the exact same circuit as last time, where we are going to get an LED and just turn it on. So do that first. And then from there, some of the other ones that we're going to go over real quickly. I'm not going to go through I'm going to go through the code and explain it. I'm not going to live code it up today, just because of time. We might actually have a little longer of a show today because I do want to get through everything, but we'll see, which is why I pre-made these. So we have the LED, then next to it, there's a button between all those circuits. There's a button right here. So we'll plug it up to the button and program it so that when I push the button, it turns it on. And we can control different ways of that. Then over here in the middle, this white, it's hard to see it against the breadboard, but this is a RGB LED, red, green, blue. So it has 4 wires coming out of it instead of 2. And that way you can hook it up and say get different mixes of colors. I can get purples and oranges and all sorts of things. Then on the end here, we have a buzzer. If I turn this on, it gets loud. So if I do it, I'm only gonna play the sound for like half a second. Buzzers are annoying. But you can make like pianos and stuff using them if you code them, right? I think I've played like programmed jingle bells on here once or something like that. Or I think I did make a piano where if you push the button, it plays certain pitches and tones at different lengths. Maybe we'll build a piano on here. Then we have this guy, which is the ultrasonic sensor. It just shows, and we'll use a serial monitor to get data back from it and be able to read that, which is usually how I do a lot of, like, just like with that robot, how I do obstacle avoidance. And then hidden over here between all these other wires, I did have a different wire kit that I was telling you about last week. For these, they're better for wire management, honestly. So I don't have a bajillion wires sticking up all over the place like I do now. If you look closely, I think I use like 3. Yeah, there's like over in this corner, like 2, 3 of them. So you see they're like flat against the board, and it's a lot more space efficient than like these guys floating around everywhere. Yes, and so then the last one over here in the corner, hidden way down, is a temperature sensor. So it can just pick up like what is the temperature in here right now. So you'll find that out soon too. That comes in handy for a lot of other projects as well. So what I'm going to do is I'm going to go ahead and pull up our first example. I have a lot of them open. Cool. So I have this one. It's called Blink. Like I said, I'll share all the resources to this in the Discord, rather than just like dropping it in chat because it's long. But the basic premise of this, like I said, it's about Spark Fun, so you can look that up. So if you were here when we were learning P5.js, it's similar in the fact of there is a setup and there is a loop. And what that basically says is, you see this void here, it means we're just not returning anything. Nothing is like going to come out of these functions, but they're an integral part. You can't, if I took away setup and loop, this wouldn't work at all. Like it would just not do anything. And it would give you a bunch of errors at the bottom saying like, what's going on? This isn't how this works. So setup basically is where you initialize everything you need before you actually utilize them. And you can do like global variables too, which we're not using in this example, but we will use later. So the important thing to know first off, in your setup, we have this pin mode. What pin mode does is going to identify on your Arduino when something is a pin. So just like I plugged in on the sides of the Arduino, there were lots of different numbers. Let's see if I can pull it up here. Yeah, I can put it up there a little bit. There's all these numbers along the side, and there's these headers, and you can plug in things to those headers. So when I say pin mode, it's a built-in function, and it's saying pin 13 is going to be from now on set as an output. So we know that, we're doing an LED. LEDs, it's not like we're reading anything from them. We want to put something out there instead. Versus, say, a button, which is an input, because we need to read the data from it in order to do something. So we set that initially. 13 is our output. Then down here in the loop, which is what's actually going to be working, the actual thing that runs and keeps going in circles, is going to all be contained inside of here. So, it's very simple to use this. It's based off C. If you've used C before, you shouldn't have too much of a hard time. Python is usually pretty easy to switch between it too, because this is just a similar. It takes C and it cuts out all the extra stuff. It's like this is the very basic we need in order to make this work. So, the first thing we'll do, it reads from top to bottom everything in that loop from top to bottom. Say we made like a random other function outside of it, it's still going to ignore it unless I put it in here. So digital write is basically saying I want to set something. I want to set 13 to high. Basically turn it on. Turn on the LED. And the reason we're using digital write is it's a 1 or a 0. It's either on or it's off. So it's digital. Later, I'll show you one that is analog write. I believe that we do that's on analog write. We have to use very specific pins in order to be able to do them. But it's so that we can have a spread of values instead of just a 1 or a 0. Does that make sense a little bit? Instead of saying 1 or 0, I could say 1.1, 0.2, 0.3, and you can have make things flow better than just having it on or off. I'll show an example of one that fades in and out for that. So we do that. Then we delay by 1,000. Basically, don't do anything for 1 second. So it's just looking at this in milliseconds. So for 1 second, do nothing. Yes. In the chat, I see says that isn't analog write technically digital, but just simulates. It does. It's technically still digital. On the board, there are pins called PWM pins, pulse width modulator, and it basically is gonna get 1 and 0 and flip them really fast so that it seems like they're analog. And then you have to set, of course, to say analog write versus digital write. So I'll show an example of that right after I do this on and off one. And then we'll do the button one, and then we'll just keep going from there. See how far we can get. So yes, we're gonna delay it for 1 second, just cause. We can change it so it blinks faster, but we don't want to blow my eyes out with really fast lights blinking. And delays come in handy in other cases, like when we're doing buttons, to prevent bouncing. We'll talk about bouncing when we get to the buttons. So it turns it off, it has it on for 1 second, doesn't do anything until I tell it to do something. So if I just stopped it at this, then it just stays like it is. Then I'll go and I say, now get that pin and turn it off. Wait a second. And because this loop is going to infinitely go, just like in P5JS when we're doing loops in there, and that main function is just going to keep going until I unplug it. And then as soon as I plug it back in, it's still going to keep going because that function is, that program is set to be in that board forever, in theory, forever. So now that I have that up, I'm going to go back to showing you this screen here, and go ahead and code it up or connect the cables so that we can do that. So here, I have a bajillion things on my desk, pardon it. I'm like, I just got this board like earlier this morning, and then I was telling you about my helping hands. They're here, they're not built. Basically, they're like this, and I have a light and a freaking magnifier, and basically you connect all these to a stand, and then they can just like be here, and you sit here, and I can bend them all different ways so it can hold things in place for me if I need to solder, or if I'm connecting things and it's just being stubborn and little parts bowl, which is my favorite thing because losing screws is headache inducing to say the least. So let me slide some of this out the way. So here we are. So this is going to be the same circuit as last time. We have our LED here, and we have a resistor. It's a 220 ohm resistor, and that is going to the negative side. That resistor is also connected directly to ground on our board. So I went ahead and they vanished. I have the red and blue cable. I always stick with my red and blue cables. I'm going to plug red into power and then black into grounds. And so now this whole strip is lit up. So I just want to make sure that nothing else is connected to power, or else, well, there's not really, or else nothing's programmed except for what I'm about to program. So we should be fine. So I'm going to get this ground, and I'm going to go ahead and connect it to our ground on the board. There's a couple different ones. There's 2 on this side, and there's one on this side and 2 on this side, depending on which circuit we work on. We're probably going to move these cables around. And then this power, instead of plugging this LED into power, we're going to plug it directly into the pin, because it's still going to get power from the board. It might not get 5 volts of power, which is what we usually would use for power on this. There's also 3.3 next to it you can use, but in this case we're just going to plug it straight in because we don't need that much power. So I'm going to connect the other side, the positive side, and I'm going to connect it to pin 13 because of course that's what we told it. We told it 12, we plug it into 12. So 8, 9, 10, 11, 12, 13. Gotta double check because they're aligned, but it's still hard to tell at times. So now we have our circle. It's going to have power from there to the LED, through the LED, through the resistor, and out to ground, and do that in the circuit. So now I'm going to switch back to the code. It's going to be a lot of switching back and forth between stuff today, guys, just so you know. I'm going to go ahead, in order to write it, what you have to do, you go to your tools up here, you select the board. In this case, we're using a Uno. There's all sorts on here. I think I've used a Nano, a Uno, a Duo. Yeah, my very first one I think was a Duo, and I think that's it. I think that's it so far. I really want a lily pad because they're circular and you can like sew them onto clothes. So it makes really cool stuff. So once you pick the board, you also have to pick the port so it knows what it's talking to. Mine, I only have one connected, so it only showed COM3. It's not pre-selected for you, so you do have to like go over here and click it. It's just set up for me because I've been testing it all day. And then you can go ahead and you can verify it. You don't have to. It's basically like it's going to simulate it on instant and see if there's any errors. So you verify it and then upload. And if I go back to show you what we have now, we have a blinking light. Comes on for a second, off for a second, on for a second, off for a second. So it's very simple to do, like LEDs, digital lights, things like that. And just let it ride. And like I said, this is going to go on forever until I stop it. If I unplug, say, this one, let's say I just unplug this one, it's still running, but it's not doing anything. And then as soon as I plug it back in, boom, and we're back. So that's that one. And then we'll pull up really quick one that shows the analog version of this. I can find it real quick. It's a lot more in depth, this one. We're gonna move it to 9. So I'm gonna go ahead, I'm gonna just do it real quick on my board and just move that to 9. And what this code basically is going to do is it's not the same thing, but it's going to fade it in and out. So we made some initial variables up here globally. We have LED is going to be set to 9. That way we don't, down here we don't have to put 9. We can say LED. It's better coding. There's a thing, I think I just learned this I have a class at Make School called Debugging, Testing, and Architecture or something like that. And they were talking about how you should never use the actual numbers when you're writing code. If you're going to use numbers like this, it's better to go ahead and initialize them above and then use the words. It's better for readability. And then it's just, I forget what the exact reason was for why we shouldn't use it. If anyone has any ideas in their mind of why we shouldn't use the actual number versus the variable name, let me know. So they're called magic numbers. That's what they sounds like. They have a weird name to them, but I totally forgot. But magic numbers, they're when your numbers going on in here and you have no idea what they are. And so, like for instance, it's 30. For us, this 30 wouldn't be too bad. But say if I just had a bunch of 9s thrown around here, someone might come in and be like, "What is 9?" So if I go down here, set 9 to the LED, that's taken care of. And 9 is a pulse width modulation. When you get an Arduino, if you look at it on the side, the numbers that are pulse width modulators, they'll have squiggles. They'll squiggle in front of them, so you know it like is analog. Then we set our brightness to 0. We start with a fade amount of 5. In our setup, same thing as before, we say our LED is going to be an output. It gets pretty crazy later, and we'll go through that later. When I show you the Knight Rider one, I have a way to set it up where I just say like for every, all the LEDs are like from pins 5 to 10, and then I say for every pin in this list, assign them as outputs. It makes the cleaner code. It just saves me a little work. So I'll show you how to do that on that show. Yes, magic numbers. So to do this one, we start off analog right, and we set our LED to whatever that brightness value was. So up above, it starts at 0. Then every time it goes through the loop, it's going to increase by the amount of fade. The brightness will change. So say brightness increases by the fade amount, and set that to our new brightness, which will then go back up later. And then we say if the brightness is less than 0, and this is OR, these double lines here stands for OR. Depends on which language you use, what your OR is, but in our case, it's like something based off C, is these double brackets. So, or if the brightness is bigger than 255, because in RGB, it goes from 0 to 255. So if it goes outside of those bounds, then make our fade negative, and then that way it goes back down. So basically, what we're doing in this code is we're ramping it up brighter, and then we're fading it back lower. So I'm going to go ahead and write that because the circuit is going to be the same. And then let's share it and we'll see. Cool. Looks like it's working. So now we have our LED, and it's just fading in and out rather than just flickering like it was before. So that we're gonna do anything else with that one. We're gonna do the button one really quick. We might go like 15 minutes over today, see if we can pump through all of these, since a lot of the beginning was a lot of chit chat to catch up to what we were working on. So we want to do the button one next, or do we want to do, and maybe if we get close to time and we start getting like that, then I'll ask you all which ones you want to see amongst the ones that I did that are probably the more interesting of them. Actually, I'm going to skip the button because we did the button last week, and it's basically the same, only coded. And the only difference in the code is when you initialize it, you will connect the button to a pin as well, and then you'll write in your code pin mode button, and you set it as a input rather than an output. We're not going to go too into that at the moment because I want to get to some of these other ones. Just going to skip straight to the RGB LED and show how you can do different colors with that one. So let me go ahead and pull up the code for you all for the RGB. There's a lot of files open on my computer right now. I apologize. 1 second. Get it up. RGB and share. Okay. All right. So going through this code real quick, we see we have similar where we have an initial setup. We set these as constants in this case. Don't necessarily need to, but they really truly are never going to change, at least for our purposes. We have a red, a green, and a blue pin. So like I said before, on the tricolor, sometimes referred to as tricolor, sometimes referred to as RGB LEDs, but let me see if I can put it up to my camera. Nah, a little bit. You see they have 4 pins on them. 3 of which are actually the colors, 1 of which is ground. So we'll take in power through our board that way, through the color pins, and then we'll connect ground. Otherwise, I already have it set up, and I'll show you how that's connected in a second. So this is just going to be the time that each color shows for our purposes. In this case, they want 1 second. They come down here, and we have all our pins. So we set red, green, and blue all as outputs. Even though it's one device, because they all have to be programmed separately into their own pins, we have to set them all up separately as well. So those are our outputs. And then in here, we're not going to do a spectrum. Yeah, well, I might switch it to spectrum too. So in our loop, we're using another function that are defined down here, and this one, main colors, which is going to show all the different colors. So if we look at that, basically it's just a bunch of turning things on. So we have, in this function, we're going to turn them off, and then for red, we turn on the red pin, turn everything else off. Green, turn on the green pin, everything else off. Go like that. When you get to like yellow, it's red and green, turn them both on. And say if we, well, we're probably not gonna go too in depth into this, but later down here, you can like do a lot more, do a lot of other things. But for our purposes, we're just gonna go through the basic colors rather than doing like analog versions of it. So before I hook it up, let me go ahead and finish showing you guys how it's connected. So I already got it set up a bit. Right here, I have the LED itself. And then I have, bend it back. I have 3 resistors. The furthest to your left, so this one, yes, to your left, that is going to be red. And then the next one right next to it, I don't know why it's set up this way. The very next one is ground. So there's a little small thin wire running in between right there. I have a pointer. Let me just use this. It's right here. And it's running to ground. I kind of circled it. So it's this grayish looking cable. And then the next two both go through resistors and they go from blue and then yellow. So let me switch that. So it's in that order. Red, blue, red, ground, blue, yellow. And then we're going to connect those 2 pins according to what we programmed them as. So red was in 11. This is on the other side of the board. We disconnect this circuit, but we ground still. So red is in 11. Blue is in 10 and yellow is in 9. I might have to double check that. Yeah, let me double check. No, red is in 9. Blue is in 10 and yellow is in 11. Yeah. Cool. So right now it's just, you see there, it's flashing red. Or it's fading in and out red. There we go. So it's fading in and out in red, and that's because I haven't rewrote the program on here. I haven't pushed it until I'm finished setting it up. So at least we do know it's working, and we know fade works on it because fade was set to pin 9, and so it's still like just only paying attention to that one pin and turning it up and down. But if I go ahead and compile it and upload it, then it should switch. Well, so you see that button on there flashing, saying that it's doing stuff. And then we have our colors. So we got off, red, blue, or green, blue, yellow, purple, white, and purple. Yeah, there's another color in there I didn't catch. Cyan, that greenish blue color. So you can do this, and it's just going to continuously go through that loop until we're done, basically. So that is how you do that one. Not too complicated, I would say, in regards to like going from that code or going from just a basic LED to doing one like this. The only difference is you're plugging up a few more things and probably have to write a bit more code. But even the code is pretty similar. It's just a lot of copy and paste, to be honest. And there are ways to do dysfunction or other things like this where it's more, we call it dry, which is do not repeat, where it's another thing we are taught at make school, how to make like clean code. Don't repeat yourself. So make your code dry. So if you have the same thing over and over and over, then just write a function to like loop through it one time, or however many times you need to loop through it. So a lot of things, even though, like I mentioned before, like make school doesn't have a direct like robotics path, a lot of the code that I write now is based off of like the things that I've learned in like my computer science classes or SPD, which is our product development class, and can utilize it literally anytime I write code for anything. So because of time, I don't think we're gonna get through all of these. So let me see. We're not gonna do the buzzer just because it's annoying, to be honest. I'm not plugging that up. It's honestly the same as an LED. You just turn it on and off. The only difference is you can have like a different file of like pitches, and you can read from that file and say like, hey, set it to this pitch. But we're not going to go into that. But if you want to see it in the future, let me know. And you can do something like that. Like, so we can maybe code like a piano or something. A bunch of buttons. Get a bunch of buttons and make that. So let's see, remember trying to make an RGB LED fade smoothly through the whole spectrum. Yeah, it's a lot. I think I had it on here. I just hadn't tested this prior to doing this. I don't really want to get too into it, but not too. So, so yeah, Jules, I see that you tried to make a RGB LED fade smoothly through the spectrum, and it was harder than you thought. It is quite complex. I'm going to do a quick test while we're here. I'm just gonna run this code, and I'm gonna switch it. I think you all can still see. So that, and see if this will work. Oh, yes. Okay. So I didn't code this, like I said, this is from Spark Fun. So I'll share the link if you want to work on that project again. But they do have a function in here where it does this fading. And I think I did a similar project to this back in the day. And I also was like, why is this so complicated? Yeah, actually, now that you mention it, I'm having a flashback. Yeah, and let me pull the code up so I can show you all kind of what's happening to that. So first I turned off this main colors, which is this, and then the other one, which was commented out before and is here now, um, gradually fades through the colors. So if I go all the way down, skip past the main colors, go to show spectrum, we're doing a loop all the way through. It's calling this RGB function for 767 times. So then we go back to RGB, which is down here, and it's just a bunch of math, a bunch of math. So we're not gonna go into like what's happening. Like I said, I'll share this code out to the Discord if people want to look at it, and learn more about it. But it's mapping like the color between 0 and 767, and a lot of if it's between these, do red to green. Yeah, I think this is something similar to what I did when I did it. Is if it's between like 0 and 255, go from red to green, alternate its intensity. Otherwise, go green to blue, alternate its intensity, blue to red, and do that. And then that's where those analog writes come in, where you're saying write to it not only on or off, but write to it in a spectrum of values. You know, just like you physics or yeah, usually I think you learn it in physics. Digital is just when you look at the graph, it's kind of just like boxes, like lines up and down, versus analog is like waves. It's smoother. So we would do it this way. So that's how we got that other one. This is how we got this rainbow. Let's see where we at. We'll probably do one more. I will do one more. We'll go a little over today. And then if you want to see the other ones, or if there's other like ones you want to see, like I said, we're probably gonna go ahead and do this one because it's my favorite. But like I said, we have the temperatures over here. There's the buzzer. There's this LED screen that we can code some stuff to. There's what's that other thing I was gonna do? There's a potentiometer, which I don't really think I have one. I'll see if I have one, but it's basically a knob, so you can alternate like intensity with the knob, like a stove. And then there's photoresistors, um, and photoresistors measure light. So if I like put my hand over it and cover all the light versus this, I can alternate like the intensity of the light bulb. And those are kind of like the things that are in your phone. When you've set it to like auto brightness, then you go outside and it dims photoresistors. Um, what's the other thing? And then we have motors and servos. That might be a whole nother. Motors and servos are hard. A whole nother thing on a whole different show. We have a lot of shows to do, so stick around. We're gonna be making a lot of things because the more I do this, the more I'm like, oh, 1 hour goes really quickly when we're talking about electronics. So we're gonna have to do a lot of shows to cover a lot of things. let alone working on the actual robots instead of stuff like this. But we're just gonna go with it, see what happens. So I'm gonna go ahead and get let me get the code for this one. Actually, I'm gonna go ahead and explain the circuit first. I'm gonna go ahead and unplug all of these guys. I'm pretty sure I'm gonna move this. Yeah, I'm gonna move these to the other side of the board. So I'm gonna unplug this too. So I'm going to go ahead and put our power and our ground because we're going to use the actual 5 volts from the board this time. I'm going to go ahead and I'm not going to plug in the power. I have this thing where I never plug in power until like it's ready, which I think is the best practice. Don't plug power into anything until you're like ready to go because you will burn out parts. And I've burnt out parts that I really wish I hadn't, but it happens. But if I can avoid it, then I will try my best. So the premise of this, like I said, it's like a bat. It sends out a signal and it bounces it back. One side reads the signal, one side puts it out. So it tells you down here which ones they are. So that's why there's 4 connectors. It doesn't come like this, of course. It comes like this. And then I got a bunch of male to female headers in order to compensate. And male to female headers are pretty explanatory. They're like insert sockets on one side and then pins on the other side. So that, so you'll have here VCC, which is your volts. The next one is trig, which is your trigger. Then you have echo, and you have ground. So those are the ones, the echo and the trigger are the ones that are giving and receiving the data. So the basic setup for this, let's see if I can scoot it. It's a little closer. This is why I usually don't use these wires because they're hard to deal with. But I was in a rush, so I was like, "We're just gonna do it today." In the future, cool. I didn't realize you could see it, but no. So we have this farthest. We said our VCC, our voltage, and is going in this white cable to the red line for power. Then at the end, which is ground, which is the yellow wire, we have it going directly to ground as well via the orange cable, or the short orange cable, the loopy one. Then the one next to it is orange, which is our echo. And we're going to set that one up to our pin 10, and then this is going to be our pin 9, which is our trigger. I'm going to plug those up real quick to 9 and 10. Not going to connect power again because right now that other LED circuit is still programmed onto here. And so it's going to try to do stuff. If I have it send it and try to alternate things, I don't know what's going to happen. It might burn out the circuit if I try to just set those high and low via as if I was using a LED. I'm going to pull this code up. It's not too horrible, but it's going to show a few different things. Some cool stuff with this that I really like. And so start off the same. This is different code from somebody else. I can share this with you all as well because I couldn't find any of my examples. And I was, like I said, in a rush. So we set our trigger pin to 9, our echo pin to 10. I just want to verify that's exactly what I did because I get confused. Red, blue. Triggers, red. So cool. Okay, I double check that. So we have some floating values, duration and distance. You see what'll come in. We set up both of the trigger as our output and our echo is our input. So the echo is the one that's like listening for what the trigger just put out. Trigger puts out the signal, echo receives the signal. Then we have the serial dot begin. So the reason we're using a serial port is because we're writing things from this to our computer. This just sets the interval for us. The default is 9600. And we can talk more about serial in a different show as well, because that's a whole thing. But for now, we're basically just initializing and say like, hey, start reading things from the serial port. Then we're going to write this to low. We're going to wait 0.2 second, 2 microseconds, just to like see if we hear anything, set it high. It's going to send out the signal, wait, turn it back off. So it's like, hey, trigger pin, turn on, send your signal out, and then stop sending your signal out. Always start with things low. Then you're going to pulse in. So rather than continuously reading anything or writing anything, you're just gonna like do a quick like snapshot from your echo pin, turn that on. So basically echo, I need you to do a quick read of what just went out there and set that as duration. See how long it took for that to happen. The distance, we're gonna convert it. This is their formula. I'm not sure why they chose this exact way of doing it. You could do distance equals duration. You could set it up any sort of way. But for this example, they just made a formula and say they're going to convert whatever that time that we get into a distance. Then you're going to print to the serial display distance. So it's kind of like if you were like in Python, you'd say like print distance. If this was C, we would say C out, double bracket, distance, whatever other languages. Basically, we just want to see it says distance. And then on that line, we're going to say what the actual distance is. Wait, do it again. So I'm going to show how this works in 2 ways. Well, let me just run it and plug up the power to the line. And we're going to go ahead and upload this. All right, it says it's done uploading. So I am going to open, if you go to your tools, there's serial monitor, serial plotter. If you do serial monitor, and I share that screen, so you can see here, it's just showing all of the data that is getting in. So I don't know if I could show both of them at the same time, but what I'm basically doing, I can hold this up directly in front of me. So right now it's faced up, so you're not really getting readings. It's not going to be perfect. It's still catching stuff. It might be catching the ceiling. I forget how far these things read, but right now it's saying the distance is 120 to 148-ish. If I put my hand in front of it, then immediately the number drops down. And then, you see some fluctuations happening there. It's not perfect, and it's going to freak out every now and again. But as I move my hand away from it, work for me, then the distance is going to increase. As I get closer, the distance decreases. So this is usually how I do most of my obstacle avoidance robots, because it's simple. In this case, I can just say like, hey, right now it's reading, well, now it's freaking out, and it just hit maximum. Let me share this back to that. So, I can have it set up like this, and then I can have another function that reads from here and says, if the distance is less than 20, turn left or stop moving. Things like that. And that's just how you just don't hit stuff. We humans do it all the time. We look with our eyes and we're like, hey, there's that thing that's like kind of close to me. Let me move. So that's one way to do it. And there's other things. There's IR readers. I don't think I have any IR, which is infrared. Does the same thing, but with infrared signals versus ultrasound. So this is doing it with a very low sound. So there's that. So when I did that robot that we were showing you the other day, he's a little gutted right now. He's not a little gutted, he's gutted because I took the Arduino off him. This uses an ultrasound. So when we get to programming this guy here, he's going to utilize some of this code where I say, get it, and I want you to move based off of the readings that you're getting from there. Let me do a quick check and see if I can plot it really quick. Let me do this, and I can pull up the plotter. Yeah, all right, so I'm gonna show you one last thing, and then we'll probably wrap it up today because we did go a bit over time. Like I said, I'll put the resources in the Discord so that you can see those, and I'll also put some of the other parts I have so you can let me know if like you do want to see these other ones or if we want to just focus on the project. The next build that I'm gonna show you, which will be that Larson scanner Knight Rider looking thing. But the last thing I want to show you is this serial plotter. If you go to the same place that we were at before under your tools, and instead of clicking serial mapper, whatever it's called, instead of putting serial monitor, you instead said to show the serial plotter, you'll get something like this. And it's doing the same thing, but it's reading those values and plotting them on a chart. And you can do all sorts of editing for this. So right now, is pointed, let me put it back in front of me, it's pointed face up at the moment, so we're getting these low values. So doing it flipped because I didn't set up like how exactly I wanted to do this, but basically right now nothing's in front of it, it's reading low values, and I put my hand in front of it and it jumps back up, and it's like, oh yeah, let me put it, they can get it consistent. Oh no, there is really low. Yeah, you have to do like a lot of mapping and stretching to get this to work the proper way. But you can see if my hand's not there, it flatlines around like, I think the actual value was like 140 something. And then let me see, I wonder if I can just zoom into it real quick. No, I don't think it's gonna let me. Yeah, can't zoom in, unfortunately, on this one. But basically, it's flatlining because nothing's really in front of it, and it just stays that way. And then once I put my hand in, then it consistently drops down to lower values, almost at 0, because I'm about to touch it. So, like I said, you can use that for optical avoidance primarily. You can use it for really a lot of things. You can use it for like alarms, like door alarms or something. It's like, hey, someone's approaching, and like just that signal off. So there's a lot of cool things you can do with that as well. So with that being said, I'm gonna wrap up the like building parts of things, and I just again want to invite you all to come back here every Saturday, 2 p.m. Pacific, 5 p.m. Eastern, and then every time zone in between there for more electric vision entertainment, where we discuss tech thoughts and thick hair every week. I want to thank you all for being here. Make sure to follow our Twitch so that you catch this live and have the real experience. You can interact with me while we're building things. Again, let your friends know, let your family know. I'm sure someone else is interested in learning how to build cool robot stuff. So let them know, invite them to come sip tea. I actually had tea here today and then I forgot because it was a little, a little dangerous. Like I said last week, I was afraid to spill it. So it's just sitting there looking at me. And as well, again, join our Discord, make.sc/join-discord. And that way you can get access to these resources. At least for the current moment, we'll do it that way. And like I said, as we proceed, we'll do it other ways. But that's always your one-stop shop for finding everything you need to know in relation to this stream. Brian's stream, Tech Topicals, is right after hours. Our other work shows, like Aldrin put on a machine learning workshop this morning. And then just interact with a tech community. It's not just students from Make School, staff from Make School, it's people who are interested in coding and computer science and robotics and other things related to tech. I definitely want to invite you all to come there, find out more. Again, like I said, let me know what type of things you want to see, suggestions you have for like the video, or for editing, or for lighting. Send me robots kits and I'll build them. And We'll see. We'll build them. And generally we'll talk and we'll find a place somewhere on the internet where I can put all these resources for you all so you can get the schematics for how these are set up, both the picture version and the actual schematic version. We'll learn about those later, as well as like what the parts are, what the code is, and all of that good stuff. So again, thank you all for coming, and I want to wish you all a good rest of your day, and I will see you next week. Bye.